Dear all, have a great day. Here in this video, today we are going to look at example 31 in chapter 6, applications of derivatives. Here we go. Have a look at this problem, example 31. A water tank has the shape of an inverted right circular cone with its axis vertical and a vertex lowermost. Its semi-vertical angle is tan inverse 0.5. Water is poured into it at a constant rate of 5 cubic meter per hour. Find the rate at which the level of the water is rising at the instant when the depth of the water in the tank is 4 meter. In this problem, what they have given is a water tank has the shape of a inverted right circular cone. And it has been given that its semi-vertical angle is tan inverse 0.5. And what they have done is pouring water in the tank at the rate of 5 cubic meter per hour. If we do like this, what will happen is the height of the water will increase gradually. Here what we need to find is the rate of change of water level when the depth of the water is 4 meter. That is, when the height of the water is 4 meter, we have to find the rate of change of height of the water. This is what here we need to find. So first off, draw a diagram of the water tank. The diagram of the water tank is shown in figure 6.20. First off, let us take R be the radius and the H be the height and alpha be the semi-vertical angle of the water tank. Then from the diagram shown in figure 6.20, what we can say is tan alpha is equal to R by H, because tan theta becomes opposite side by hypotenuse. Therefore, from the diagram, what we can write is tan alpha is equal to R by H, which implies alpha is equal to tan inverse R by H. But it has been given that alpha is equal to tan inverse 0.5 in the given problem. If we compare these two, what you get is R by H is equal to 0.5 and 0.5 can also be written as 1 by 2, which implies R is equal to H by 2. Now let us take V be the volume of the cone. Then what we can write is V is equal to 1 by 3 pi r squared H, because the formula to find the volume of the cone is 1 by 3 pi r squared H. Therefore, V is equal to 1 by 3 pi r squared H. In this formula, replace R by H by 2. Then what you will get is 1 by 3 pi into H by 2 whole square into H. It will become pi H cube by 12. Therefore, V is equal to 5 H cube by 12. Here what we need to find is, first off, differentiate both sides with respect to t. Then what you will get is dv by dt is equal to d by dh of pi h cube by 12 into dh by dt, because here v is given in terms of h, so that is why differentiate v first with respect to h and then differentiate h with respect to t then. So we have dv by dt is equal to d by dh of pi h cube by 12 into dh by dt. So here 5 by 12 is constant, take it outside and then differentiate h cube. So what you will get is 3h squared. So it will becomes 5 by 4 h squared into dh by dt. Now the rate of change of volume is dv by dt is equal to 5 meter cube per hour and h is equal to 4 meter. It is given in the problem itself. The rate of change of volume of the water tank is 5 meter cube per hour. And what we need to find is, we need to find dh by dt when the depth of the water is 4 meter. So here we have taken h is equal to 4 meter. So replace these values in this dv by dt. Then what you will get is Phi is equal to pi by 4 into 4 squared into dh by dt. Here what we have done is, in place of h, replaced 4. So that is dh by dt is equal to 5 by 4 pi, and then replace pi by 22 by 7. Then what you will get is 35 by 88 meter per hour. So dh by dt is equal to 35 by 88 meter per hour. Here dh by dt is the rate of change of depth of the water. Therefore, the rate of change of the depth of the water level is 35 by 88 meter per hour. This is the answer we need to find. Thank you.